raise her
All right,
interest to it.
so
She was like,
we
this is
have a lot
amazing. Miss
to do
Lorraine, this is
today.
amazing.
We have a lot to do today.
Hey, one time for that. Okay.
First thing I want to say is this. I know that you have to think a little bit more about the problems we're doing right now. But perseverance is a key characteristic to being successful. You can't always just whine, complain, and give up. You gotta fight, fight, fight. So, first thing we're gonna do is practice 3 more equations. These are not identities. These are the equations where we solve them and get like x equals pi over 6 and stuff like that. Right? Let's not worry about our eyebrows right now. Now is the time to worry about that. Alright? So we'll practice 3 equations. Anybody have any idea why we might be practicing some equations?
We're gonna get quiz. When? We're gonna get quiz.
No, I don't think it's.
Guess on Monday because we don't have class Friday.
Alright, does everybody have one? Alright, here we go. Practicing to get better. We are practicing to get better. So we're missing Peter and Lucy and Sydney. Okay. All right. So yes, there is a quiz in your future. The quiz will have one problem. And it will, this is not the quiz, this is practice for the quiz. It will be one equation that you're gonna solve. So, let's build our confidence. Let's not be frightened. Think about solving this equation. What would you do? I know what I would do. I would add 3 and square root both sides. So tangent squared equals 3. And tangent then equals plus or minus the square root of 3. Now, if that had been, let's say, a 4, then I could factor that if I wanted to. Tan x minus 2, tan x plus 2, the difference of squares. I can still do that with a 3, but it's not a perfect square. I'd have to use radicals. So it's just easier to move the 3 over and take the square root of both sides. Okay, you've done that a million times in your life. Probably not with tangents, but otherwise. Now, where is the tangent positive or negative? Everywhere. So I'm going to draw my butterfly bow tie, every single piece of it, understanding that all these triangles are congruent. But there's going to be 4 answers to the question. So let's just look right here in quadrant 1. If the tangent is root 3 over 1, right? Root 3 over 1, then you should know how big that angle is right there. That's a 60. But the directions are in radians, so I won't say 60, I'll say pi over 3. 180 divided by 3. So all of these angles are pi over 3's. Is pi over 3 then one of my x values? Yep. Now the next one is going to be this purple one.
2 pi over 3.
It's 2 pi over 3, which is, as Chris said, pi minus pi over 3. Then I got the pink one,
4 pi.
which is 4 pi over 3, or pi plus pi over 3. And then I have the last one, which is all the way around to here, 5 pi over 3, which is 2 pi minus pi over 3. Now, you guys can do that. You can do that. It is not tricky or hard. You can do it. I have complete confidence. Let's look at the next one. Can we do the next one? What do you think when you look at this guy? You think about factoring it. At least I hope you think about factoring it. What will the factors be? It's a nice little quadratic. So 2 cosine and cosine. -1 -3, Chris says, is he right? Double check your factoring. If you screw up the factoring, then of course you're going to get the wrong answer. Thank you to the many of you who have brought in your cereal, by the way. Friday's the last day.
Does it go to a food pantry where?
It goes to, I think I talked about this already, maybe I didn't. Did I not talk about this with you?
No.
Okay. History of the cereal drive, in case you wondered how this all got started. There was a family here, I'm gonna say 10 years ago, but I could be wrong on that. It was a while back. And they had a connection with Dayspring, which is a homeless family shelter. I don't know what the connection was, but anyway, the oldest kid came to me and said, hey, we wanna have a cereal drive with the math department, offer, of course, extra credit. And we said, sure, you know, whatever. Well, the first year was a nightmare because the first year I made the huge mistake of just saying, you get a point for every box you bring in. Oh my gosh. They couldn't take it. We ended up taking, you know, like a truckload to Gleaners because these other pantries couldn't handle it. It takes a lot of storage to store that stuff. So anyhow, now we have the limit on it. But anyway, so that kid ran it pretty much. I mean, he'd organized his friends and his parents, and they just took care of everything. All we did was give the extra credit. So then the next kid, his brother came. He did the same thing. Then their little sister came. She did the whole thing, the same thing. Then they graduated. So, of course, the math department, being the math department, said, well, we can't not have a cereal drive. So the math department did it 1 year, and then since then the National Honor Society has taken it on as a project. We do Dayspring Homeless Shelter still, that's what our roots are. We also do Holy Family Shelter, which is a Catholic family shelter. And then we also do St. Vincent de Paul Food Pantry. We also give some to our own St. Nick's Nook here at Cathedral for kids who need support here at school. So it's all very worthy causes. Please bring in your cereal. Okay, sorry for the diversion. Now we're back to this. So this says cosine equals 1/2 or cosine equals 3. What did we talk about this yesterday? What did we say about that?
That's
That's a no-go. Cosine cannot be bigger than 1. Okay? So that one is out. All right. Where is the cosine 1/2? Well, certainly quadrant 1, but also quadrant 4. That is not something that we memorize. You can, certainly, but that's something we know because cosine is x. And if it's going to be positive, it's got to be on the right side of the coordinate plane. All right, cosine 1/2. That makes this root 3. Do I have the same angle? 60?
Oh, because it's adjacent.
But this time, I only have it in quadrant 1, so pi over 3. And then in quadrant 4, which we said was 2 pi minus pi over 3, or 5 pi over 3. And we discussed this yesterday, that we just don't know when we start the problem how many answers we're going to get. So our 2 examples so far, this one had 4 answers, that one has 2. All right, last one. Now, a word of caution. If it looks quadratic, it is quadratic. I could subtract this over, but is that going to be factorable? No, because that's a sine and that's a cosine. This one was cosines and cosines, that's good. So what do? We talked about this yesterday too.
Turn the cosine into a sine.
Turn the sine squared into a cosine. Remember, they're only changeable if they are squared. The Pythagorean identities change your functions. So since sine squared plus cosine squared is 1, sine squared alone would be 1 minus cosine squared.
Could you minus the 1 over? Then minus the cosine to make a negative cosine squared?
You absolutely could. That's what's going to happen because these ones are going to cancel.
Yeah. Same.
Wait, but what it is that like cosine is still the equivalent of 1 over sine.
What?
Never mind.
That's on video. Okay, so here we go. Everybody makes mistakes. Okay, as long as we get that cosine is not 1 over sine. The only way, listen to me, the only way to change a sine into a cosine is to do what we just did. That's how it's done. Okay? All right. Now, just to back up a minute, Finley said, I would rather subtract the 1 over here. So I had cosine equals sine squared minus 1. And then sine squared minus 1 would be negative cosine squared. Manipulate that. You see if you bring the 1 over or take the cosine over, see how that's true? He's going to end up exactly where we are because these 1s are going to cancel. Subtract 1 from both sides, they're going to cancel. So we have cosine equaling negative cosine squared. That's what we have. Now what do you do with that? We've talked about this too. You gotta move something. I would bring this over so it's positive, but you gotta get them on the same side, and then you can factor. What you cannot do, guys, is divide both sides by cosine. That is not legal. So you move everything over and then factor it out. As soon as you get it factored out, you can set your factors equal to 0. So cosine is 0, and basically cosine is going to be negative 1. Right? Now, Neely, if you want to come up and sit next to Julia, no one sits there. Right up here next to Julia. Now, in my other 2 examples, I drew a triangle. I am not going to draw a triangle in this case because, think about it. If I tried to draw a triangle whose cosine was 0, that's what it would look like. Can a triangle have a side of 0? No. So if I can't draw a triangle, then I'm going to have to look at my circle, right? And where on the circle is cosine 0 over 1 or 0? Pi over 2. Exactly. Cosine is 0 right here and right here. So the 2 answers to that part of the problem are pi over 2 and 3 pi over 2. 90 and 270. Now, if I try to build a triangle with this, think about what that triangle would have to look like. Wouldn't it have to look like that? Is it possible for these two sides to match? Again, no triangle possible for that. So back to the circle. Now I need cosine to be -1. Where does that happen? Right here. This is where x over r, or x is -1. So there are the answers to the problem. Okay? Next time we have class, Friday, you're gonna get a half sheet of paper. Actually, I think I put it on a whole sheet of paper. One problem. Like these.
Oh, it's one of the solves.
One of the
Let me
solves.
get the cute little
It's exactly,
the
it's exactly like the ones we just practiced. Now, understand every equation is different, right? But we've done a bunch of skills here, and so you'll have to use whatever skills are necessary for your equation.
Do we get to use the purple sheet?
Did I need it for anything on
Yeah.
here?
Oh, yeah.
No, I didn't.
That one right there you did.
Okay,
The cosine and
I want you
sine.
to memorize sine squared plus cosine squared is 1.
We don't get the sheet.
You don't need it for this one. Not for this quiz. Not for this quiz. You don't need it.
So if it doesn't matter, can we still have it?
No. No.
Wait, so we have to memorize the whole sheet? Well, I know you said for the quiz, sine squared plus cosine squared equals 1, not like for future.
No. You do not have to memorize the whole sheet. However, I have the whole sheet memorized. Right? I didn't sit down and memorize it. I memorize it as I do problem after problem after problem. So ideally by the end of all this, you will have at least some of those things learned, right?
Hopefully.
That everybody has memorized, right there. Everybody has that memorized.
Yeah, I got it.
Okay.
It's not a goal one.
Now, I want to pause for a minute and do a couple of homework questions.
Oh, let's go.
So if you turn yours in and you want to get it out.
I started to watch your new resources. It's like watch a video.
I'm already ready.
Did you start it?
Are you ready? Okay. Now, I am not going to do every single homework problem, but I will do a couple for you. So, raise your hand into the air. Who has a question about one of the homework problems? Sabrina.
Did you do 4A, please?
4A. It says simplify. So what simplify means is exactly that. Somehow we gotta figure out what this is gonna boil down to. Now, everybody in this room should look at that problem. And I don't care what's, science, but I don't care about, all that. You should see a fraction plus a fraction. When we have a fraction plus a fraction, we should get a common denominator, okay? So our common denominator is 1 minus cosine and sine. That's the common denominator. So this one needs a sign. To have the common denominator, I need to give it a sign. This one, I need to give a 1 minus cosine. Now, both fractions have the same denominator, that's the point. So they can be combined into one fraction. Sine squared plus, okay, what will I do here? FOIL. So 1 minus cosine plus cosine squared. Right? Now, what do you notice about that top? First of all, do you see this and this? What does that make? 1, and there's another 1, so I have a total of 2. And there's 2 of those, so 2 minus 2 cosine. Now, do you notice anything about the numerator? I know somebody say you can factor out of 2. And what's so awesome about factoring out the 2? And we're left with 2 over sine, which is perfectly okay. 2 over sine is considered simplified, but you could actually write that as 2 cosecant, because 1 over sine is the cosecant. But 2 over sine is fine. Okay? One more. Yes, Josh.
3C.
3C is another simplifier.
Left-handers only have the same
Now, this problem, I think, is going to bring up an algebra point that I want to make, because I think it'll make your life a lot easier. First of all, if I'm simplifying this, I am going to change everything into sines and cosines. Now, that's my own personal style. We talked yesterday, there are different ways to approach it, but whenever I simplify, I like to get sines and cosines, because they're like the base units. Like in your Lego set, I mean, they're like the keys to getting it started. So 1 plus sine over cosine over 1 plus cosine over sine. That is called a complex fraction. It is a big fraction made up of smaller fractions. Now you can get a common denominator, and invert and multiply. That will always work. Dividing by a fraction, multiply by the reciprocal. I don't do that though, because it's too much writing. I'm a little too lazy to do that. I'm gonna look at the whole thing, the whole shebang. The common denominator of all 4 pieces is cosine times sine. So I am going to multiply all 4 pieces by cosine times sine. Even if you choose not to do the problem this way, please pay attention to this strategy, because it will make your life easier at some point. So I look at the entire problem. My denominators are 1 cosine, 1 sine, so my common denominator is cosine sine. Now, what happens when I multiply? Well, I end up with cosine sine plus sine squared over cosine sine plus cosine squared. Now, let's understand, because of these plus signs, don't be canceling. Okay, you can't. The only way you can cancel is if you factor first. So, does the top factor? You can take out a sine. And we're left with cosine plus sine. We can take out a cosine, and we're left with cosine? Now, sine plus cosine is nothing, but since I have the same thing at the top, I can cancel them, right? And I'm left with sine over cosine, which is considered simplified, but sine over cosine is also tangent. Now, I really don't have time to do this, but I want to go back and I want to look at this problem from a different viewpoint, because I want you to understand you can always do the problem lots of different ways. So if I go back to the beginning, another way to think about the problem would be to think about cotangent as 1 over tangent. Right? Now, again, that's a complex fraction. The only denominator is tangent, so I'm going to multiply everything by tangent. And I'm going to be left then with tangent plus tangent squared over tangent plus 1. Now, what can I do to the top? Take out a tangent. And as soon as I take out that tangent, what am I going to have left? 1 plus tangent, which is going to cancel with the denominator and leave me with tangent, which is the same thing I got the other way. Okay, it doesn't matter. There's no bonus points for either one. Get it done. Whatever occurs to you, get it done. All right, one more and then I'm done. One more. Kylie? 3D. 3D is another simplified. Okay? Now, we haven't been at this very long, but we've probably been at it long enough for you to know what I'm going to do. I'm going to change the whole shebang in the sines and cosines. So, the numerator is a multiplication. So the numerator is one term. 1 over cosine squared sine. That's what's up there. That's 1 over cosine squared times 1 over sine. That's one term. You can write that as one fraction because it's a multiplication. Right? It's like 1/3 times 1/4 is 1/12. All right, now the denominator you can't do that with. The denominator is going to be 1 over cosine squared plus 1 over sine squared. Those are separate terms. If you say, well, I don't want to divide, I want to invert and multiply, you can't until you get this together. This has to be together before you can do that. You can't flip individual fractions. So what I'm going to do is what I did before. What's my common denominator for the whole problem? The whole thing, the common denominator, cosine squared and sine squared. So I'm going to multiply everything by cosine squared and sine squared. So what do I have left on the top when I do this multiplication? Cosines are gone, one of the sines is gone, so I have sine on the top. Everybody see that? And then what on the bottom? Those cancel, so I'm left with sine squared. These cancel, so I'm left with that's just sine. Yes, that one just simplifies down.
So right there, there's multiplying by sine squared, sine squared. Wouldn't you just end up, like, wouldn't that cancel out the entire fraction?
That's whack.
No, because that's not squared.
So that would leave you with
Yeah, so it's like when we have to point out that's true or not.
Just sign it.
So, what I want you to do, guys, is, when does that due tomorrow, right?
Yeah.
Spend a little more time with it, if you want to. You don't have to. Remember, as long as you give your best effort, it's okay if you miss some. But we've just worked through 3 of them. Think about it a little bit more. Maybe spend a little more time with it, bring it tomorrow morning, or tomorrow sometime. Or you can turn it in now if you want. I don't care. But we're not doing any more of them. That's all we have time to do right now. Okay? All right, practice makes perfect. So we're going to keep practicing our identities. Our goal is to get 2 more done today. Let's see if we can get 2 done. And if we do, I'll stop and do more homework or something. I'll try to get 2 done. So here we go. Cosine t over 1 minus sine, and 1 plus sine over cosine. Now, especially when we're first starting this, there is a very common mistake made with a problem like this. Remember, you are proving this, which means you don't know for sure that those are equal. Your job is to prove that they're equal. So somebody might be thinking, hey, I'll just cross multiply. No. Remember, if we're proving they're equal, we're changing one side into the other. You're not involving both sides in the action. So you're going to pick a side and change it into the other side. I don't care. These are going to be exactly the same amount of work. So what?
Change the right side.
Change this into that?
Yeah.
Okay, that's what I'll do. So this is staying the same. I'm not changing this. Now, also, I want to remind you that sines don't become cosines unless they are squared. So don't be getting any kind of crazy ideas over here. But wait, let's think about this for a second. That's what I have, and this is what I want. My answer, I'm going to think of this as my answer, because this is what I'm shooting for. My answer has a cosine in the numerator. What if I just put a cosine in the numerator? Now, that's perfectly legit, as long as I also put 1 in the denominator, right? Now, Miss Ford, why would you do that? I just told you why I would do that. Isn't that what I want to end up with? I don't have a clue what else to do. So I say, okay, I need a cosine up there. I'm going to put 1 up there. Now, did that open any possibilities for me? Look at what I have.
Oh, it's
and
squared.
look at what I want.
It's squared now.
Now that's squared. So can I change that into sines? What is it when I change cosine squared into sines? What does that become? What's cosine squared?
1 minus sine.
1 minus sine squared. Who just said that? I thought so. Miss whining and complaining about having to know sine squared plus cosine squared is 1. Yeah, you know it already. Cosine squared is 1 minus sine squared. Wait a second though. There's too much stuff here. Something had better cancel over here, right? But what did I tell you? Oh, I gotta factor it. No canceling until you factor. So what factors in that?
1 minus sine.
1 minus sine squared is the difference of squares, isn't it? And how does the difference of squares factor?
Not perfect square. It's like x minus 5, x plus 5.
1 minus sine, 1 plus sine, right? Either order, doesn't matter. It's like x squared minus 4, x plus 2x minus 2. It's the same exact concept.
Could you go about it, like, it definitely wouldn't be as quick, but could you go about it by like, not factoring, but like multiplying the 1 plus sine t times cosine t?
You mean up here?
No, right, like right down there. If you didn't, like, could you multiply that top half first together?
You can distribute it, but
Yeah.
it's not gonna accomplish anything, because my whole goal is to be able to cancel, and the top is already in factored form. If you put them together, you're gonna have to split them back up. So what did we end up with? Exactly what we wanted to end up with. Okay, so we're kind of just storing some things in our mind. Every problem is different. Every problem is different. So the only way you're gonna, be able to conquer this is to start making a repertoire of stuff to do. So what did we learn here? Well, if we can't think of anything else to do, we can just stick something in that might help us. And we did that reasonably. I mean, we said, okay, I need a cosine, so I put a cosine in there. I wouldn't have put a tangent or something in there, right? I could have. And then, this I think is the first time we've run into the difference of squares. These happen all the time. Because every time you change a cosine squared, it's gonna be 1 minus sine squared. And you're gonna be able to factor that. It's gonna be the difference of squares. It happens over and over again. Okay, well, that wasn't so bad. Let's look at this next one. Ay, let's take a look. This is our last problem of the day. We'll stop. And I'll take more homework questions if you wish. But I'm not going to get you started on this one. I'm going to take it as a suggestion from the audience, and we're going to see where it goes. And Maren has her hand up.
I think I just put it back down, actually.
Okay. It's all right. Do you have an idea? You have good ideas. Go ahead.
Well, no. Hold on. Well, like, I feel like it would be easier to change the left side, because I feel like it's easier to get rid of a fraction than it is to make one. I don't know if that makes sense.
And I agree with you, but here's where my mind is going next. Aren't there fractions over here? I know physically there's no fraction,
Yeah.
but are there fractions over there?
Yeah.
So if you can work either way, doesn't matter. My thought is there's 1, 2, 3 functions over here, and there's only 2 over here. I don't know. I'm lazy. I'm thinking, oh geez, I'd have to change these into that. We can absolutely do it. If we did that, Maren, what would be your first thought over here if we did that?
Oh, you could change cotangent and cosecant, right?
Absolutely. There is that's a
I have to
square.
look at my purple sheet for that though.
That's a Pythagorean identity, because there's a square there, and any squared function has an identity that goes with it. And that identity is 1 plus cotangent squared equals cosecant squared. So you absolutely could change that. I'm gonna just throw out a bit of a warning there to you. If you work here, this is gonna be your answer, right? It has a cotangent in it.
Yeah.
Okay, that's okay, but over here, once you get rid of that cotangent, at some point, you're gonna have to put it back in, which is, we can do that, we put a cosine in our problem a minute ago. Okay, so that would be an option. Leah's been over here trying to say something, though, I wanna give her a chance.
That's what I was gonna say.
You were gonna say that too, and it's all fine, we can do that if that's what you want, Dom?
You could change the tangent on the right side into 1 over cotangent.
Okay, I could, I don't know what's gonna happen when he gets, so let me do it. So Dom says, I could change this into 1 over cotangent.
But like,
I don't know how it helps, but it just makes it so that there's
Okay,
only
so you could do that, so here's the deal, kids. As long as you're doing, you know, legal things, it's okay. But it may take you nowhere, and you may need to go back and come up with a different plan. So,
ooh,
I think,
wait.
oh, go ahead.
Or, well, if that, on that plan, I was thinking, so first you change your tangent to 1 over cotangent. You could change your secant into 1 over cosine. And your cotangent, well, that would make sense actually.
Well, but you can change tangent into something else. It doesn't, it could be 1 over cotangent.
Yeah, or
But what else could it be?
sine over cosine.
Okay, so what happens if we do that? Does that help us at all?
Yes.
So we have cosine, oh, that's not, cosine over sine times
Wait.
1
Oh, yeah, sorry.
1 over cosine minus sine over cosine. All right, so if I distribute, I'm gonna have cosine minus cosine sine all over sine cosine. We could factor out a cosine and actually cancel it, if that's what you wanna do. We gotta kind of pay attention here to what's happening. We could do that. So now we have 1 minus sine over sine. Keep an eye on my arithmetic, did I do that right? Well, guys, what if we took what we have and we said, okay, I'm done messing around, I have no idea where this is going, but I gotta end up with this in my denominator, right? So what if I just did, in my denominator, 1 plus cosecant u, and then on top, 1 plus cosecant u. Is that legal? Now,
How do you get to that thought? How do you get to that, like?
I have no idea. I'm doing what you guys said, I'm following all this around. I'm here, and I wanna be here. I gotta get something in my problem, because first of all, that's a squared, and I'm not even close to a squared over here. I'm gonna see what happens if I just put into the denominator what I want in the denominator. Now, do not multiply out the denominator, because if you do, you will lose what you want. So leave the denominator alone, and with any luck, we'll be able to cancel that out of here. Well, let's see, what do we get when we FOIL on the top? We get 1
Minus
plus
sine.
cosecant minus sine. Okay, wait a minute. What's sine times cosecant?
Wait.
They cancel. Because what's the relationship between sine and cosecant? They're reciprocals. So when you multiply reciprocals, you're going to get 1. So it's going to be minus 1. The 1's cancel. This is getting big. I'm pretty sure a shorter way to do all this, but we're powering through. So we get cosine, this is where I am now, cosine minus sine over sine 1 plus cosecant. Or that was cosecant, yeah, cosecant.
Oh, you can't cancel the signs yet, can you?
No, because you haven't factored the numerator.
Can you? Well, you could get rid of the, oh, we got rid of the signs. Oh, you could take out a sign.
Yeah, 100%.
Take out a sign.
So I heard somebody say, change this guy into 1 over cosecant. Is that what you want to do, or do you want to go the other way? The other way?
This is scary. This is like, this is the trenches. This is for.
This is the trick.
This is the trenches.
Don't change this one, because with any luck at all, that's, we're gonna end up with that.
Oh, okay. Hold on.
I'm starting to see the plan come together.
Really not.
Yeah, watch. This is a complex fraction, so I'm gonna multiply everything by sine. And as soon as I do that, look at your numerator. 1 minus sine squared.
Don't you have negative sine x squared on the top?
You have 1 minus sine squared. And then on the bottom, you have sine squared 1 plus cosecant. Hearts are pounding, right? We're getting pumped, because what's 1 minus sine squared? Cosine squared. So now I have a fraction where I have cosine squared over sine squared. By the way, that is cotangent. So I have cotangent squared over 1 plus cosecant. Woo! That took perseverance.
Wait.
But what it illustrated is that even though I was taking suggestions from various people, so there wasn't like really one plan, we were kind of hodgepodging it, we eventually made it. Whew. Kylie?
When we get to like the test, like how do we like not run out of like time? Like if you get kind of unlucky.
You go as long, I mean, you take whatever amount of time you have and then you're done. But remember that everything you write down, as long as it's right stuff, is points.
Okay.
So you can actually get more partial credit on a problem like this
Right.
than you can on one that has like solve for X.
Right.
Right?
Okay.
So I'm not gonna worry about it. I'm gonna do my very best. I'm gonna go whatever path I think, and if I get stuck, I'll just draw a line and start over. Okay? And we have extra paper over there. If you get stuck and need more paper, you can do it. We gotta practice this, guys, though. So getting frustrated and worried and scared, no. Practice. Right? Okay. I can't even remember all the things I did there because I erased it. But, yeah. All right, so we will do
Wait, for the
the rest of them next time.
Yeah,
You can probably start working on your 5-2 homework right now. I mean, this is what it is. We have got to still keep practicing, but you can try. All right, I have 5 minutes. I am, this fried some brains. I'm perfectly okay with either calling it a day or with doing another homework problem. So what do you want?
Wait, what was that?
Call it a day.
Call it a day or do another homework problem.
Okay, compared to chapter 4, this makes so much more sense.
What?
I went like faster.
Compared to chapter 4, this makes more sense. Highly.
This is just accurate. Chapter 4 was like
Okay.
a lot of weird stuff.
That is fair, that is fair. This is like stuff that we like already